We use fractions for many different uses. Fractions can be used to communicate a value and to calculate a value. Different forms of fractions are useful in each case. Different forms of the same fraction can look very different. Below, we have 5 different fractions: 12/24, 1/2, 2/4, 4/8, and 3/6. All 5 of those fractions have the same blue area colored in. They're broken up differently, so our denominator breaks up the whole differently, and our numerator represents a proportional amount of that new whole. The simplest form of this fraction exists within the fractions listed. However, all of these fractions have the exact same value. Which one do you think is the simplest form? Either use your definition of a simplified fraction, that being a greatest common factor of 1, or look at the visual representation of the fractions. Each one hints at the simplified value. These fractions are all equivalent fractions. Equivalent fractions have the same or equal values. Think about the United States Constitution. All Americans are equal, but we all look different. They all may have different numerators and denominators, but as you move from one fraction to the other, you find a scale factor, a value that's going to help you keep these values proportional. Since they have to remain proportional, we end up using proportions to deal with these mathematically. For example, if a value was missing and we were trying to find an equivalent fraction, we use cross multiplication when we have 2 equivalent fractions set equal to one another in order to find a missing numerator or a missing denominator. Since these equivalent fractions are proportional, if I know one of the other pieces of information, I can find the missing value. So I'm going to start by multiplying the values at a diagonal from another. So 6 times 5 gives me 30. 2 times x gives me 2x. That's why it's called cross multiplication. It makes like a little x when you do the multiplication. Then I'm going to divide both sides by the coefficient of the unknown value. So the value that's right next to our x, it's the number that's being multiplied by x. We divide both sides by that. Now, when we do this, what we're doing is canceling out that coefficient. 2 divided by 2 is 1. Anything divided by itself is just 1. 1 times x is just x. 30 divided by 2 gives us 15. So that middle value is 15, or the denominator is 15. If you simplified 2/6 and 5/15, you would get the same simplified fraction, that being 1/3. There's also a calculator shortcut that you can use. Multiply the 2 values that are on a diagonal from each other, so 6 times 5, and then divide by that third value. So 6 times 5 is 30, divided by 2 gives me 15 again. It's the same exact method, the same exact steps that we just did, but it's more conducive to doing it on a calculator. Let's try a couple problems together. We cross multiply. 12 times 4 gives me 48. 2 times x gives me 2x. Divide both sides by 2. I get x equals 24. If I wanted to double check that, I could put 24 in for x. 2 times 2 gives me 4. 12 times 2 gives me 24. So my scaling factor is 2. If we wanted to use the shortcut method, we would multiply the 2 values that are kitty-corner from each other. 12 times 3 gives me 36. I'm going to write that value down so I can keep things organized. I'm going to divide by the third value, the one that's kind of off by itself, or it's across from the x. I'm going to divide that by 9. It's going to give me x equals 4. On your own, try the other 2 problems. Fractions fall into 2 separate categories, one being proper fractions and one being improper fractions. Let's look at proper fractions first. With proper fractions, there are less individual parts than parts in the whole. So if I have a denominator, so the number of parts my whole is broken into, if I have a denominator of 10, and I'm only looking at 3 of those individual parts, 3/10 is proper. In other words, the numerator is smaller than the denominator. These are less than 1. I have less than 1 whole. Improper fractions are quite the opposite. there are more individual parts than parts in the whole. So let's go back to our original whole. It's still broken into 10 individual pieces, but we're looking at 12 of those pieces. So we're looking at the 10 in the whole and then two more tenths. The numerator in this case is bigger than the denominator. We're looking at more individual pieces than the whole is broken up into. What that leads us to are values that are greater than 1. Because we have more than a whole, and we know that when the numerator and denominator are the same, we end up with 1. If we push past that and make the numerator bigger, now it's 1 plus something else. The images above help to clarify proper versus improper. On the left, we have a proper, elegant lady with a big bustled dress. She's very bottom heavy. On the right, we have a guy who, if he showed up to the same party as her, would be considered improper. Wearing a giant Texas hat or giant cowboy hat really makes you not only look top-heavy, like an improper fraction, but very improper socially. Let's try finding a couple improper versus proper fractions below. Circle all the proper and put a box around all the improper. 4/7 is proper, because the numerator is smaller than the denominator. 3/10 is proper because the numerator is smaller than the denominator. 3/5 is proper because the numerator is smaller than the denominator. 2/13 is proper because, again, the numerator is smaller than the denominator. The denominator is broken up into 13 equal pieces, or the whole is broken up into 13 pieces, and this fraction represents 2 of those pieces. 9/2 is improper. Its numerator is bigger or greater than its denominator. In this case, we have a whole that is broken up into 2 pieces. We have 9 of those pieces. That means we have 4 wholes and then some. 8/3 is improper because the numerator is greater than the denominator. 7/3 is improper because the numerator is greater than the denominator. Mixed numbers are another way to communicate different forms of the same value. They're technically equivalent fractions, but we call them something different. Mixed numbers are great for communicating math, not necessarily calculating math. Instead of telling someone a recipe calls for 3/2 of a cup of sugar, you might tell them instead it's 1.5 cups. Mixed number represents more than one whole, just like improper fractions represent more than one whole. So mixed numbers are equivalent to improper fractions. It's made up of a whole number and a proper fraction. So this is when you see one whole value, a big value, next to a proper fraction, a fraction that has a numerator that's smaller than its denominator. These two together tell you how many wholes and then how much extra, really how much change you have left over. Let's look at a couple examples. In the case of a pie, my pie, one pie is a whole. I'm going to cut that pie into 4 slices. Now, I have 2 pies represented here, but they each represent one whole. So if I broke my one whole into 4 pieces, my denominator is 4. I'm going to eat 5 of those slices because I'm very, very hungry. I just had 4 pieces, which made one whole pie. To get that 5th piece, I would have had to eat part or a fraction of the next whole pie. So I ate one whole pie and 1/4 of a pie. So there's all 4 slices, and then there's my extra 5th. So I have one whole and 1/4. On your own, try the same example with money. Mixed numbers are great for communicating math, but to use multiplication, division, addition, subtraction with fractions, especially improper fractions or mixed numbers, we need them in that improper fraction form. It makes all the operations much easier to deal with. So we need to know how to convert between the two. Both mixed numbers and improper fractions represent values that are greater than 1. So these values are equivalent. We've established this. We can go from one to the other, just like we can solve missing values in equivalent fractions. In order to do this, to go from a mixed number to an improper fraction, we're going to multiply the whole number, so that in this case is 4. It's that big number that's out by itself, by the denominator of the proper fraction, because we have a whole number and a proper fraction linked together. So I'm going to multiply 3 times 4. 3 times 4 gives me 12. And I'm going to add this product to the numerator. This is now my new numerator. So 4 times 3 is 12. 12 plus 2 gives me 14. Keep the denominator the same. The denominator is always going to be the same. So I have a new numerator of 14. My denominator is 3. My fraction is 14 over 3. Then I would simplify. Now be careful, because usually simplifying means turning improper fractions into mixed numbers. However, in this case, if I were going to add or subtract or multiply or divide this fraction, I would want to leave it as an improper fraction. Just simplify the numerator and the denominator by finding the greatest common factor and dividing top and bottom by that value. Let's try this together. I'm going to multiply my denominator times my whole number. 8 times 5 gives me 40. I'm going to add this new product to my numerator. So 40 plus 1 gives me 41. The denominator stays the same. So my denominator is 8. My numerator is 41. There's nothing that can be done to simplify that one. This next mixed number, negative 3 and 3/7, is a negative mixed number. The whole value is negative, not just the 3. So this is a good rule of thumb, something to look out for. If the mixed number is negative, the improper fraction is negative as well. A lot of people look at negative 3 and 3/7 and they assume, well, that's negative 3 and then that's positive 3/7. They're put together through addition. So whatever sign we have at the beginning, it has to be the same. Otherwise, we'd have to do a calculation in here. A lot of people look at that as multiplication because they're next to each other. Mixed numbers have more to do with addition than multiplication. Do not treat the whole number as a negative value. Where that comes into a play, a lot of people will do 7 times negative 3 and give negative 21. Don't worry about signs when you're converting from one form to the other. If it started negative, it'll end negative. Don't worry about positive versus negative, positive plus negative. Don't worry about any of that. We just need to worry about 7 times 3. The sign will stay the same no matter what calculation you do, because the whole value is negative. So I do 7 times 3 to get 21. 21 plus 3 gives me 24. My denominator 7 stays the same. I get negative 24 over 7. I could put that negative sign out front. A good rule of thumb when writing improper fractions, put the negative sign in the numerator every time. It'll make calculations with the 4 major operations a lot simpler. On your own, give 7 and 4/9 a try. Since improper fractions and mixed numbers are equivalent values, we can easily move from one to the other. We can turn mixed numbers into improper fractions to calculate, and we can turn improper fractions into mixed numbers to communicate math. This is also part of our simplifying process. So I'm going to look at my fraction here, 7/3. It's improper because the numerator is greater than the denominator. I'm going to divide the numerator by the denominator. I'm going to do this with long division. Using a calculator will just give us a decimal answer. So I'm going to take 7 and divide it by 3. 3 goes into 7 2 times. 3 times 2 gives me 6, and I'm left with a remainder of 1. So 2, remainder 1. Each piece of this long division process tells us something about the mixed number. The whole number value is the whole number of the mixed number. So our 2 is going to be the whole number, the big value in our mixed number. The remainder is the numerator. The denominator stays the same. So we have our 3 pieces of information. We're going to have as a whole number 2. We're going to have as a numerator 1. And our denominator 3 is the same. We would then simplify the fraction portion. Always simplify the fraction portion. You know you've done things correctly if you end up with a whole number and a proper fraction. If you have an improper fraction next to a whole number, you didn't divide properly. Let's try another couple here. So I'm going to do long division. I'm going to take 17 divided by 8. 8 goes into 17 2 whole times. When I subtract 2 times 8, 16, I get a remainder of 1. The whole number 2 is my whole number. My remainder 1 is my numerator, and my denominator, which was originally 8, stays 8. Just like when we went from mixed numbers to improper fractions, the negative does not affect the calculations. So negative 13/7 starts negative, it will end negative, and we won't deal with that negative sign as we make the conversion. So I'm going to do 13 divided by 7. 7 goes to 13 one time with 6 left over because 1 times 7 is 7. 13 minus 7 gives us a remainder of 6. The number that we got out, the whole number, that 1 is our whole number in the mixed number. Our remainder 6 is our numerator. Our denominator started as 7, ends at 7. Always check if you can simplify the fraction portion of a mixed number.